so this is 49. Don't get there. We do have a quiz this week. It's going to be at the end of the week. Everything we cover today through Wednesday, possibly Thursday, will be on the quiz, okay? We are starting over with our new 9 weeks. That means you have 100, and then you have to keep it as best as you can, keep 100. And you have 9 weeks until the end of this grading period, which means 9 weeks left of school. Yes. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. 9 weeks left of school. It'll go by quick. Okay. Pythagorean Theorem. This is something that is from a man called Pythagoras. His name was Pythagoras. And you use it in right triangle trig to solve for a missing side of a triangle that you can't find. There's a couple of vocab words we need to talk about, and then there's a couple of conditions that have to be met, and then we will dive into practice problems. So we have this right triangle here. How do I know it's a right triangle? The little square tells me it's a right triangle. There's a right angle in it. I want you to go to the right angle and draw an arrow from the right angle to the side opposite. We practiced this in the last section. What is the vocab word to describe that side? Louder. Hypotenuse. This is the hypotenuse. That was me trying to write HYP. It didn't come out good. There we go. This is the hypotenuse. It's really important that you know how to identify the hypotenuse in a right triangle. When do you use the Pythagorean theorem? You use it to find the missing side of a right triangle. Right triangle means there is an angle, measure of an angle equals 90 degrees. There is an angle in the triangle that is 90. You have to know that that's true before you can use Pythagorean theorem. It does not work with random triangles. It only works with right triangles. Do you remember the vocab word to describe the sides that form the right angle? Legs. So sides A and B are called legs, and side C is called the hypotenuse. Does anyone by some miracle remember what the Pythagorean theorem formula is? I'll give you a hint.
Isn't it A?
Yes. So A squared plus B squared equals C squared is the formula. And what it means is there is a relationship between the 3 sides of a right triangle. If you take the legs, square them, and add it up, you will get the same number as if you just square the hypotenuse every time. It does not matter how you identify the legs. It doesn't matter which one you call A, which one you call B. What does matter is which one you call C. That matters, okay? Before we come right here, I want you to take note. If you hear exact answer, or if you read exact answer, it means they don't want any rounding. No decimal rounding. So I'm going to draw an arrow to suggest it means no rounding. So typically, it means you're going to have a square root of something that may not be pretty. For example, I'm going to write EX, for example. If you came down to the square root of 3 as the length of a side, they don't want you to type square root 3 in your calculator and get the decimal. They want you to just leave it as square root 3, okay? Because this is exact. If I was to actually square root the 3, everybody go to your calculator, type square root 3, you're going to get an ugly decimal. Square root button, you're going to have to hit the second and then it's the square button on the left. You're going to get an ugly decimal. Notice which one is shorter to right. Square root 3, right? And notice that there's no rounding involved with square root 3. So that's the difference between what's called an exact answer and then what's called approximate. Or some people pronounce it approximate. I'm going to draw a dotted line to represent that this is a different thought process. If you're told to approximate your answer or round your answer, if you're straight up told to round, I don't think you need any clarification. You're going to get an ugly number and they want you to round it, right? But if you're told, I want you to tell me the answer, give me the approximate answer, it means there is rounding. So, for example, if square root 3 was our answer, and let's say we were rounding to the nearest 10th. Everybody look at your calculator. If you're going to the nearest 10th, I'm going to draw a squiggly line because it's way more than what I'm going to write. Can someone read to me the two numbers after the decimal? It's 1 point what? 1.73. So if I'm going to the nearest 10th, then that means I'm looking at this digit right here. This is the one I'm going to decide if it rounds or not. And this is the one I ask myself, is it high enough? Somebody told me there's a rhyme. Like, all right, 5 or more, raise the score. 4 or less, let it rest. There you go. So if this number that you're checking is 5 or higher, then you do bump the digit that you were rounding to up. If it's less than 5, so if it's 4 or less, let it rest. Let it rest, meaning leave it alone. So in this case, if I was going to the nearest 10th, it'd be 1.7. Let's draw one more thing and do a refresher on rounding. There is no domino rounding. How do you spell domino? Is there an E on it? Or is that Domino's Pizza? No. Spell domino. There is no E. She's still talking to me. Okay, thanks, Sarah. So there's no domino rounding. What I mean by domino rounding is where, like, you go and you check a number and you say, oh, that raises it. So then that raises this one. So then that raises this one. That's a domino rounding. There's none of that. Now there's a difference in, and when it comes up, there's one scenario where it's not domino rounding, but people think it is. When it comes up, I'll show it to you. But if I say, I'm just going to draw some digits. Ready? Let's just do 0.00000. Okay. Everybody already knows this as the what place? 10. How many? So the way you know what you're rounding to is however many zeros are in that number. If I say round to the nearest 10th or tens, there's a 1 0, so you're rounding one digit. If I say round to the nearest 100, look how I'm writing this. I'm turning my paper sideways. Oh. If I say round to the nearest 100th, there's 2 zeros, so there's 2 numbers after the decimal. What comes after 100? 1,000. So if I say round to the nearest 1,000, there's 3 zeros in 1,000, so it's 3 numbers after the decimal. So you would check the 4th one to see if it was 5 or higher. I don't know how often this is going to come up, but we're going to write it just in case. The only other additional rounding position might be the 10,000s. don't know if that's going to come up, but we'll write it just in case. So how many zeros are in 10,000? 4. So that means I'm checking the fifth number after the decimal to see if the fourth number needs to bump or not. Okay? All right, so crash course on when you're told give the exact answer, when you're told to approximate, and when you're, like, in terms of rounding, okay? Now let's dive into these problems. It says find the value of x, round each answer to the nearest 10. So look at number 1. The first thing I want you to do is draw an arrow from the right angle to the hypotenuse. Label it C or label it HYP. It's up to you. And now we're going to plug this into our formula. It does not matter how you label A and B. Sorry. So we got 8 squared plus 13 squared equals C squared. In this case, all of our numbers are on the same side. So we can go straight to our calculator and type that in. 8 squared plus 13 squared. So I'm going to type 8 squared plus 13 squared, and I get 233. So I'm going to come back here and change this to 233. Now, I need C squared to be just C. So what do I need to do? How do you undo square? Square root. So I'm going to square root both sides. That's going to cancel, leaving me with just C. I'm going to go to my calculator, and I'm going to square root 233. Now the directions said round your answer to the nearest 10th. Okay, watch this. If you struggle with rounding, there's 1 0 in the number 10. So this means I'm checking the second digit. Here's what I mean by there's no domino rounding. Like, you don't come back here and say, well, that 5 bumps that 8 up, which bumps the 3 up, and then on and on and on. You don't do that. You literally ignore all of these numbers after. Rounding involves just checking one number. You're not checking everything. Okay? So the 6 is high enough, it's going to bump that to 15 point what? 3. Now, if I said, tell me the exact answer, everybody write this down. If I said, tell me the exact answer, then you would have said C equals the square root of 233. Now, I don't want to circle it because the directions didn't say give me the exact answer, but we're going to have some down the road that do. So you need to start practicing when to leave it alone and when to actually square root, okay? I personally, although this is ugly, I don't mind these because there's less work involved if it's an ugly number, which sounds weird. Okay, y'all try number 2. Try number 2, you should get 34.8. Everybody try it. Remember, I've already given you the answer. I've taken that part away. It's not a secret. You're just doing the work to get there. Now we wrote C, and it's really X, but it's okay. If you wrote X squared, that's fine. If you wrote C squared, that's fine. Did you get 1,213 and you had to square root that? Okay, let's move on to number 3. Same exact type of problem, but the numbers have a slightly different arrangement. If we draw our arrow to the hypotenuse, we see that the hypotenuse is the number 9, which means one of the legs is missing. I'm just going to call the leg as it is, x. I usually lead off with it. If a leg is missing, x squared plus 7 squared equals 9 squared. Now this one's a little different. You cannot just run straight to the calculator and like enter the whole thing because all the numbers are not on the same side. But you can be strategic about this. Two ways to do this. Figure out which way your mind lies. You can go ahead and square these numbers. You've got x squared plus 49 equals 81. Then you can subtract the 49, right? Subtract it to over here. And we got x squared equals 32. You can do that. Or, and now some people may not like this. If you don't like it, then ignore it. Let me show you something that works as well, and it's helpful when the numbers start getting ugly. If I know I'm going to be moving this by subtraction, regardless of what it is, right? Then I could just say to myself, minus 7 squared. And I could go to my calculator and type 9 squared minus 7 squared, and I'd go ahead and have 32. So there is that technique that works. If you like it, write it down and keep it in mind. You can go straight from the original setup to what you need to square root. If you think this is going to confuse you, then by all means ignore it, okay? Then just square those numbers and subtract it, and maybe try that trick another day. All right, we're going to square root. Oops. Square root, square root. Did you get 5.7? All right, number 4. Everybody try it. This is where numbers get ugly. Try number 4. This might be one of those where you want to move the 19.1 squared by subtraction instead of typing it all in the calculator, because then it'll bring you straight to that where it gets square rooted. Sorry. Did you come down to these numbers? Trying to read faces. Did y'all come down to those numbers? So like 30.5 squared minus 19.1 squared 565.44. So don't let the complexity of the number make you think you don't know what you're doing. You knew what you were doing when the numbers were pretty, like 8 and 13 or 9 and 7. Just because it's an ugly decimal doesn't change the math, right? So keep that in mind. Now, I'm going to use my highlighter to point something out to you. And let's see. It doesn't really have to be one or two. It could be these two. I'm going to highlight that and that. And then I'm going to come over here and make a note. This is scenario 1. This is scenario 2. You have 2 scenarios when you're doing the Pythagorean theorem. Either the hypotenuse is missing or a leg is missing. If the hypotenuse is missing, it's kind of a shorter problem because you can just go straight to the calculator, type it in, and square root it. If a leg is missing, you do have one additional step, sometimes 2, depending on the route you're taking in showing your math. But overall, if I throw a Pythagorean theorem problem at you, there's only one of 2 possible scenarios, so it's almost a multiple choice question in setting it up, okay? Now, looking at 5, 6, and 7, this is looking to see, can you apply the Pythagorean theorem in pictures that involve right triangles? Not just if I throw you a right triangle. This is too easy. This is more grade level appropriate. So let's come down here and look at it. This is where you have to be a problem solver. Now in this particular picture, we have a triangle, and then we have this drop down. What does this mean right here? What does the little box mean? It's a right triangle. Do you remember the math word for that when it drops at a 90-degree angle? We did this on the Thursday before last weekend. This was that worksheet that I said needed to last for 2 days. There was a word on that worksheet that told us when this drops down, and then it was blank to the base. Yes, perpendicular. So this is dropping perpendicular to the base. What type of triangle do we have? Like the big one. We have an isosceles triangle. I want you to make a note. Recall page. All right, let me go over here because I don't remember the page number. Table of contents. 47. Recall page 47. On the front of page 47, we learned that when a altitude, it's called an altitude, drops straight down from an isosceles triangle perpendicular to the base. Do you remember what it does to the base? Common sense kind of comes in here because you can look at the picture and you can be like, oh, it looks like it's doing this. What is it doing to the base? Everybody turn to page 47. Turn to 47 in your notebook. Shouldn't, just 2 pages back. Find a picture that looks like this one. Or did y'all turn it into me? You might have turned it into me. Hold on. I do have a lot of people's 47. I needed it to take the grade on the back. I've got Daryl bisecting the base right here. So this whole base is 22, but if it's getting bisected, then what is each part? 11. So, and of course I just made congruent parts and they look like 11s. So this is kind of weird. I'm going to write 11 here and 11 here. Now the directions say to find x. If this is 24 here, then what's this over here? 24. I'm going to redraw that triangle on the right over here so I have less crowding. And then now I'm just finding the missing leg of a right triangle using what? Pythagorean Theorem. So everybody find that missing leg. Did you get 21.3? All right, look at number 6. There's one shape here, right? What two shapes could I make into that picture, though? Let's be creative. By drawing a line somewhere, what two shapes could I create in that picture? A triangle and a rectangle. I want everybody to take your pencil and lightly, if you're worried you might be wrong, lightly draw a dotted line to create a triangle and a rectangle out of that picture in number 6. Draw a dotted line that would create a triangle and a rectangle. This is part of being a problem solver. Did you draw it here? Basically creating that other end of the rectangle. Do I have enough info to find the length of from here to here and then from here to here? Do I have enough info to get those measurements? You do. Take a second, look at the picture, think about what you know about a rectangle, and write the measurement, the length of just this side of the triangle and this side of the rectangle. I would love for someone to share their thought process. What did you write first?
As a rectangle, it equals 5, so let's equal 5, and then 18 minus 5 is 15.
Very good. So in the rectangle, opposite sides are equal. So if this is 5, then this is 5. Over here, if this is x, then what's this? X. And then if the entire top is 18, and I just wrote a segment as 5, then the remaining segment would be 13. Now, when you drew that rectangle, what do you know about the corners of a rectangle? They're all what? What angle? 90. So this is dropping, not dropping, I guess you could say it's going up to here 90 degrees. Well, if this is 90 over here, then what's over here? 90. So what type of triangle do we have there? A right triangle. It might help to draw it separately over here. You got 13x and then 16. And then now you're looking for the missing length. Everybody try it. make sure you're doing the Pythagorean Theorem. I'm giving you the answer, but that's not to cut your work out. That's to give you that sense of security to know if you're doing it right. Any questions on 6? All right, number 7. I would love to see you be a problem solver here. I am going to tell you that it's going to require 3 processes. There's going to be 3 parts, okay? If we're trying to find the length of the entire bottom, right? What's one thing I could find to help me get there? What's our game plan? We need a game plan. Be a problem solver. So if I'm looking for the entire bottom, focus on the entire outer triangle that goes with the bottom. So there's the bottom, there's the left, and there's the right. Is this a right triangle? We don't know, right? There's nothing marked. If this was marked as a right angle here, it would be just as simple as Pythagorean Theorem with what numbers? 14 and 29. But we don't know that it's a right angle, so we can't do that. So we have to be a problem solver. So what's the technique I can do? I'm going to highlight it. And you're absolutely right. I could solve for the bottom of one triangle. Can I solve for the other one? If I come over here like this, 12 is a shared side. That means what is it over here? It's also 12. And then this is 90. What's over here? 90. So I'm going to change colors. So I need to find the blue side. Then I need to find the green side. And then what would I do with them? If I want the whole thing, I'd add them together. Let's assign variables to those because we don't want to call them an x because x is the whole thing. That's the goal. This is the goal. Let's call the blue side A and we'll call the green side B so we don't get confused. So you're going to find A. Then you're going to find B, and then you're going to find X. I want everybody to try it right now. You will round to the nearest tenth on A, nearest tenth on B, and X you should come to 33.6. Let's see if you can get there. hypotenuse, yes. For A, did you get 7.2? A came down to 7.2. Oh, you're right. So you pulled 12 and 29 right here for this one. I named it backwards on my paper. My paper, I called this A and this B. So up here, hold on, let me fix that. I'm glad you looked at me confused. That's B. B is 7.2. A, did you get 26.4? I switched to one accident. Yeah. Okay. When you draw your arrow to the hypotenuse, you know the hypotenuse of both of these. So there shouldn't be a C. It's going to be equal to 29 squared and equal to 14 squared. All right, you have 2 more practice problems, and then when you finish these 2, you can come get the next paper, which is your actual assignment for a grade. It's numbers 8 and 9. I was going to save the 10 through 13 for tomorrow. 8 and 9 is asking for you to find the value of x right here. Well, this is going to be another one of those 2 steps scenarios, right? You're going to have to find what first before you can find x.
Do we have to do this practice paper at home? Or can we do it
You're going to do it right now. Do what?
Are we going to do this practice paper? Because we said these. We don't do this done. Do we have to do it at home and have it done tomorrow morning? Or are we going to work out tomorrow?
I would like you to work on it in Flex today. And then come to class with it pretty much done, if you can. I might, you can work on it during the announcements and then maybe to 8:10. What are you going to have to find in number 8 before we can get X? There's a shared side in there that we don't know. We need to know this, so let's call it A. You're going to have to find A before you can find X, okay? Number 9 will be, will only involve one process, but you do have to think about what you know. You have to do some problem solving with your numbers, like figuring out your sides here. You have to think of what you know about a rectangle that's right here on the middle. This is a rectangle, and you do have 2 triangles on each side. And this overall shape on the outside is an isosceles trapezoid. There's some symmetry here if you think about it. Like if this is 26, then where else is there 26? being a rectangle, what else would be 26? Do what? Coming down. If it's a rectangle, remember opposite sides are equal. So that would be 26. How much does that leave for the remaining sides? Here and here. 14. So are they each 14? No, what would they each be? 7. Alright, do 8 and 9. I'm going to put the answer, because remember the answer is not a secret. The goal is you can get here. You have to show me your work. And when you get that done, you'll come get the other sheet.